Howdy, and welcome back. Today I am going to build a thermal camera for this Raspberry Pi here. And first, what we're going to do is, before everything, we're going to be flashing a fresh install of the Pi OS here. I'm going to take this, I'm going to plug it in. Okay. Open up Balena Etcher. And flash from File. Select Target. Make sure I choose the SD card. Yo, so what's up? We're choosing SD card, and then we're gonna flash it. And while that is going, I'm going to turn on my soldering iron over here, and it's going to heat up. And I am going to start soldering up this thing. And what this thing is let's move this out of the way. This is the AMG 8833 IR thermal sensor. So basically what it is it's a thermal sensor that has an 8x8 pixel array on the inside. And that is what our camera will be. You know, if you notice, doing USB. No, Doug, I'm making the camera. Like, I don't think you understand. So, we have a sensor here. This is going to be a direct wire up to a Pi. I think this is I2C or something. Yeah, if you look here, this here is the sensor, and it is I2C. Actually, one second. Oh. I don't know. I was gonna try to get the thing. Middle school, you made a camera? No, you didn't. If you did, then that. Yeah. So here's the sensor. Okay. And what I'm gonna do is I'm gonna go grab my solder. Okay. My iron is up to temperature. I'm gonna plug this in a board here. Okay. And then let me solder this up. So we got VN, ground, SCL as a S clock, serial data, interrupt, and it says ADO, but I think ADO is a temperature sensor. There we go. That's soldered up. Yeah, you soldered up in science class. That's pretty dope. Okay. Then, well, if they taught you that in science class, bro, why aren't you doing this shit? The problem with cleaning up your office is that you have no idea where everything is. Something went wrong. What's going on? Okay, I started flashing that. Let's look here. Let's hide this display. Let's go to technical details. Let us look at here we go. Okay, let's see here. VIN. This will take the power pin. The sensor is 2.3 volts. You have include onboard voltage regulator. Take down the power board. Grab up to V out. Okay. 3VO is ADO. Okay. So this thing, I think, has a voltage regulator on it. So we are going to logic pins SCL, SDA, and INT is an interrupt pin. Logic can use it to detect when something moves or something changes in the path. Okay, cool. So then let's look up Raspberry Pi 0 pin out. Okay, so SDA and SCL power. So we can use these first 1, 2, 3, 4, 5 pins on this board. So here, I'm gonna unplug this because we're not hooking it up yet to the monitor. So here's the board, the computer that will be driving the camera. We can use the first 5 pins on here. So let me do that. I'm going to grab 5 wires. Ideally, I would use a header for this, but I'm really unprepared for some reason. I don't know why I'm so unprepared. My God, what is going on? Why is that? I'll use the RPi imager if this don't do anything. Yo, Desp, you don't understand anything. Oh man, this is embedded programming. This is the shit I'm really good at. So we're gonna use a red wire for power. We're gonna use a yellow wire for SCL. We're gonna use a green wire for SDA. Why are they so long? Maybe I'll use a white wire. Let's be racist up in this bitch. Then let's use a blue wire for, that's a black wire, blue wire. Let's use blue wire for interrupt. Let's use a red wire there for power. That's good. And then let's use a black wire for ground. Cool. So I have, is it just instructions on soldering shit? No. This is instructions on soldering, and then this is making the camera. The camera's library is for the Arduino, but I want to port it to the Raspberry Pi, and I want to make it run, and I want to use something like uh, PyQt or something to render it, and then I want to do it in C. I want to make like a C, like SDL or something, and then or frame buffer, or go to the frame buffer, and then I want to use SIMD to very quickly integrate it. So then the because the sensor is 8x8. It's literally like an 8x8 LED matrix. But you see how this, this looks really good. That's because it's using integration. But what it's doing is it's doing integration on each pixel, one at a time. With SIMD, I can do whole chunks of the image at once, so it'll go a lot faster. So that's what I want to do. So anyway, let's turn my iron back on. And we're going to solder this up. We're going to solder this one. Okay. And then we're going to solder SDA, SCL. SDA is going to be, S clock is going to be yellow. SDA is going to be white. We're going to be racist up in this bitch. Then we're going to use blue. We're going to use blue wire for the interrupt. And then we're going to use black for ground. Cool. My iron's up to temp. Again, I would be using a header for this, but I'm woefully unprepared and these are cheap. Okay. 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 Now let's solder up that power. Okay, let us take a look. I'm going to reflow each joint. They didn't all go down. Okay. Yep. 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 Okay. Cool. Okay, so I think this is soldered. Now I'm going to plug this in. We're going to do V in. What do we say? SDA is white. Okay. And SCL is yellow. And then the interrupt is blue. And then black is ground. Cool. So there's our camera. I'm going to take this and move it to soldering iron because I don't need this no more. Cool. Now let's check our flash here. Okay, you know what? I don't know why this is not working. Okay. So there's something called the Raspberry Pi Imager. Raspberry Pi Imager. Download. Which I already have. I'm going to do a Pi 02. Choose OS. Do I want it to be 64-bit? Do I want it to 32-bit? I want to... we'll do 64-bit. Okay. Let me do the settings. Okay. Okay, let's do this. I literally don't know why it's erase your man into ground or anything like that. That's not what this does. I'll have to figure out how to show off the screen with this camera because I don't have a tripod. I don't know. I mean, I had one. I don't know where it went. So stupid, right? Okay, well, let's take a look at this. So basically, go here. So we're making this, but we're not going to do it like this. We're going to make it better. So this wants to do the Python. This wants to do through Python. I don't want to do it through Python. I want to do it through C. So I want to do this. Adafruit. I'm just looking over the code. So I'm going to download these files, the C and the H, and I'm going to have to port the CPP to the Raspberry Pi. Raspberry Pi. There's like a whole song and dance for wiring Pi. Raspberry is now, oh, Wiring Pi is now pre-installed. That's fun. Wiring Pi. So I'll need to include Wiring Pi, sub GPIO, input. Okay, so let's look up Raspberry Pi I squared C temper sample C. Yeah, it's in the model. I assume it's in the model. Set up interface, dev I squared C1. Cool, it's been written. Okay. Now we're going to take this. I'm going to plug it in here into the Pi. Okay. I'm going to plug it into the Pi. And then I'm going to power up the Pi. And then I'm going to try to find the Pi on my network. And I'll make it like a static IP. And then I will start setting this up. Let's do it. Putting in the SD card. We're going to plug in here. Okay. Then we're gonna grab some micros in it. Ugh. Cleaned up my others, and now I can't find anything. And that's just how it goes. I shouldn't need that much power. My God. Of course I can't find the one cable I'm looking for. I cleaned up my office so well, and now I'm just messing it up again. Okay, well, I'm going to be using this to power everything up. 5 volt 3 amp. Now, unplug this. Okay. Then there. Okay. I think it's powering up. Wait, hang on, guys. Hey, okay. That's a lot better. Why is this not connecting? There we go. Why is this not? Why am I not getting any signal from this? What? Why is this not working? A moment. What? Is it because this isn't a splitter? Like this isn't like an adapter? Okay. You know what? You know what? I don't need this anyway. I don't need this anyway. we can use we'll use VNC. We'll use VNC. Okay, let's set this up. Okay. I am looking up the new Okay, let's try SSHing into any of these addresses. Nope. That's not what I wanted. Not that. Nope. 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 Well, let's try rebooting it. Okay. My God, this is very boring. I'm trying to get this connected to the Wi-Fi. Okay, I didn't overwrite it. To Wi-Fi on first boot. Raspberry Pi. RPA supplicant. Now let's try this. Can't believe I don't have a mini to full size HDMI. I mean, I can because it's at work. It's with my. It's with. I know where it is. I'll bring it home tomorrow. What is going on? Am I serious? Like, let me think here. You know what? You know what? I'm gonna try reflashing this again. this the Pi 02? Pi 20. Okay. Okay, let's try reflashing this because, oh my god. And of course, I don't have a mini HDMI. My god, this is. Why? You know what? Let's try porting. I'm gonna close these. What is this? I'm gonna call this. Cool. So then what I'm gonna do. I'm saving this to port. Cool. So Raspberry. Cool. Okay. Oh my god. Cool. Let's try this again. Here. Here. Plug in. Oh my god. Okay. Is this it? Yes. Okay, I found it. I had to find it in the log of my router. Isn't that annoying? Cool. Okay, I'm sorry. I think everything's fixed now. Okay. Um, let's get into this. Sudo raspi config. So we're going to turn interface options. We're going to turn on VNC. Because we can't do anything. And let me turn this display off. Okay. Right, interface options. Let's turn on I2C. Yes, I'd like to enable I2C. Finish. Exit. So then we're going to add on a new connection. Okay. So basically, this is Raspberry Pi Zero running VNC. So it's going to be a little rough, folks. But that does mean we can create stuff. So we go here, we go to new configuration, work Pi. Pi. So I want the root to be. And I'll be able to execute everything. Save. Okay, new folder. Let's do thermal. So we're going to go here and here. Cool. So now we are on the Raspberry Pi. We are on the Raspberry Pi. And let's get this working. So I'm going to pull this up into the upper window. Okay, so basically what I want is I want this to include these headers. Let me just open up a new terminal session, cd thermal. Let's do another file here. G++ main.cpp o thermal. And then how do I link? Do we need to link against anything for wiring Pi? And then do -l wiring Pi mod plus x build.sh. What? Wiring Pi, no such. Wiring Pi, no such file. You know what? Right. Install Wiring Pi Raspberry. So, how to install Wiring Pi Raspberry Pi. So I'm just gonna clone Wiring Pi. CD Wiring Pi, CD. Build. This is insane. Like it's already almost midnight. It's midnight and I'm just now trying to get the software built. But seriously, Wiring Pi is such a fantastic piece of code. It is like the greatest. I think it is the single-handedly the greatest piece of code that the Raspberry Pi community has ever come up with. In fact, I think it is what has created, like it is what has made. It is what has allowed the Raspberry Pi to be as big as it was. The guy who wrote this library was harassed so much by so many people trying to ask him to personally get him to personally tune his library to everyone else. To everyone else's boards and stuff, that he closed it off and said, I'm never going to ever do this stuff again for open source software. Yeah. So anyway, this is what I'm going to do. It says begin. Okay. You know what? You know what I'm going to do? I'm going to I'm going to flow code this a little bit. I want this library to be ported to the Raspberry Pi. Specifically, the Wiring Pi library. Can you do this? Okay, I've uploaded it, and we're gonna try just coding it, or we're gonna have. Okay, let's look. This is insane. Okay, I gotta read over this and see what it's actually doing. Oh my god. Oh, just give me the two files. Oh my god. I can't. I can't deal. Okay. Okay, sorry. Porting a Arduino library to Raspberry Pi by primary specific I2C communication utility function and a I2C device, two wire delay min and constrained with a wiring pi equivalent. It's just a ported version. I'll break it down into the necessary files. Keychain is removed out of root. Removed out of root I2C device. So let's just try changing this to this. And then rename. Okay, and then rename. Create a new header file called wiring pi squared C. Create the implementation file. That's where C CPP. Modify the header. Modify the implementation. Okay. Okay. Let's try this out. Okay. So let's copy this, which is the implementation. Let's copy this, which is the header. Okay. And then we're going to make a new file, AMG88XX wiring pi I2C.cpp. Okay. Wait, hang on, what? Create a new header file for the I2C wrapper, the H. AMG88XX wiring pi I2C.H. Okay, close. Implementation for it, copy, paste, modify the header, let's try building it. I'm gonna try removing this. Yeah. So I don't think I need that. It built. Cool. Okay. Yeah, we're vibe coding this bitch. So I just vibe coded the library. I just said, I uploaded. I'm sorry, I didn't look that, but I just uploaded the Adafruit Arduino library to AI Studio, and just said port this to the Raspberry Pi, and it did. The only issue it had was it said the length of wiring Pi Twisty library, which didn't make sense because it didn't build it as one. But anyway, that's pretty cool. So let's take this, and then let's take this. Okay. We're here. Examples. Let's try porting this. Let's try porting this to C. So what I'm going to do is, okay, let's see, AMG 833 camera test. Okay. Okay. So I have that, and I'm going to say, and if we look at an example, let's see. Okay. Cool. But basically, I want to set up wiring Pi. Okay. Hang on, we're getting places. Let's try that. Let's try that. Cool. If again std error C error could not find a valid AMG 88 sex sensor, check wiring. Okay. Else std cout AMG AXX sensor found. Let's try it out. What's going on? Let's change this to 0. Hang on, what? Okay, let's try this. Let's see, tools, scan. I2C detect. $69, that's right there. So it should be there. What? Okay, let's try Yo, Darsky. Hey, man, good night. Sorry about that, man. Um, okay, what's going on? For some reason, I am getting the message. Unable to open C device, no such file or directory. I have run this with sudo 2, and I squared sudo detect shows the camera. Yeah, webcam paying off. I don't know, man. It's paying off, but I mean, it's eating my ass right now. Shows the camera at the correct address, 0x69. Nice. Also, the delete. Let's just see what it says. I might as well embrace the future and use AI to help. Gmail's gotten better. It really has. After 2.5, it's really good. Cloud is using Ground. A lot of people at my work love Cloud. They really do. Alright. Yep. Mm-hmm. Let's just copy this directly. Let's try that. What? Hey, now I tried the continue extension via code. Basically, you can integrate the to do changes in your code, and you can use Gemini. You grab a free API key. That sounds kind of cool. I'll take a look into that. I think I know what you're talking about. Um, Why can't I open that though? Sure, Raspberry Pi. Let's try that. Why is this not working? Check permissions. LSL dev C1. Only root. To make changes, sorry, midnight. No worries. It's midnight where I live. We all probably live pretty much in the same location. Yeah, North Carolina. I mean, it's hot, as you can see. Um, yeah, it's just pretty toasty down here. Um, okay. Sudo boot. No worries, you don't know C. It's not even C at this point. This is really just I'm fighting the Raspberry Pi. I'm not fighting C. I'd much rather fight C. That's something I can win. Oh my god, I have this idea like, oh, I'm gonna make a thermal camera on stream. We're gonna have like something working by the end of it, and of course, it never goes the way you want. And it's a real shame because like, I really want this to work. Really want this to work. Okay, basically what I want is I want to get the temperatures out. I want the temperatures read out. In I need them read out in the matrix, the 8x8 float matrix. Then from there we can work on some C windowing thing. We can vibe code that shit up and just display it. I want to just display it on the screen. Basically, take that small window and just blow it up by like 10 times, and then just display it. Then we can work on the SIMD stuff to make it go super fast. Yeah, I know. I know it never goes the way we want, but I mean, I can dream, right? Don't you also love like how slow like VNC is on a Pi Zero? It's pretty insane. Okay. Here, open up a new session. Thermal. Sudo. Are you kidding me? What do the delete keywords do? Let's see if this is even being ported correctly. Nice. Okay. 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 Let's try this. So I have tried your fixes, but they don't seem to work. However, something interesting. FD in the wiring pi I2C begin function does not seem to be set to -1 because I do not get those I do not get those error messages. I still get the no such file or directory. Let's look this up. Raspberry Pi squared C1 no such file or directory. Yeah, like what is this? I've already done that. Oh, geez, what's good? If I can finally show it up, homie. Bro, I'm trying to fight this Raspberry Pi and it's not helping. It's not helping me at all. I've tried restoring my Raspberry Pi. In fact, I just tried restoring my Raspberry Pi. Yes, I want it to be enabled. What is screen sharing over Raspberry Pi Connect? Let's try restoring it again. Oh. Man, that fucking sucks. What does this even mean? sudo mod probe I2C dev. What the hell? Just remember the project. I think I'm really where there's no bugs or features going. Oh, that is the the Game Boy Advance game. I sort of like ended it mostly because I I kind of ended up doing what I set out to do. Create a somewhat functional breakout game for the Game Boy Advance with like no actual knowledge on how to do it. And I did it. And as far as as far as I know, like I've yeah, finished it. I would definitely love to like go make like an actual game, but add that to the project, to the pile of projects. I have a bad feeling that this is because apt update. I have a bad feeling this is happening because something in Bookworm is completely broken. I hate this. This is the worst. Half of this is just not having your pins correct. My God. My God. I was trying to create GTK apps. Yeah, it's actually messed up so bad. LibG. See on my Linux PC, I need to refresh install. Yeah. I I don't know what's going on. Of course, this is when I hate this about Raspberry Pi. And I've actually run into this problem many times. Something will work for so long, and then all of a sudden it'll just break inexplicably, and you cannot figure out what's going on. And I won't let you know. You know what I'm gonna do? I'm gonna print out. What? Oh, I should probably restart this. I'm gonna print out FD. Do I need that linking? Do I need that linker? Do I need the linker? Is that all it is? I got a error. Cannot find L wire. Oh. Come on. Show me how you did this. Okay. Let's try this. Because it's including it here, but I'm not linking against it. So I was right. I don't need it. My God, this is horrendous. I seriously, I tried to do something cool. My God, this sucks. Non-standard Wi-Fi, corrupt system, or environment issue, although sudo should bypass most environment problems. Shit. I just rebooted it in the middle of an update. Oh my god, did I just break it? Oh my god. Let's try this again. Oh my god, please. Why is this? Did I just brick this thing? My god. I think I may have bricked it. I swear to god if I bricked it. Hang on. Nope, okay. Okay. I was going to either do this or I was going to use a Teensy, and honestly, the Teensy probably would have been faster. I'm just telling him what errors I got. Regularly. That's oh man, dying slowly. Yeah, let's try that. Okay. We found it. It's found. Okay, we're telling him that it worked. I think maybe it was just I had to update it. Oh. Okay. Okay. Okay, so now let's do this. Um, read pixels. And then pixels is going to be a float array. It's going to be 64 in size. It's not really a float. It's just I'll tell you about it later. Okay. Let's see. Okay. Let's start. Let's start this code, boy. Let's do this fucking serious. 2D, see out. Cool. See out. Cool. Oh, sleep, man. No, dog. I can't go to sleep yet. I can't go to sleep yet. I gotta make this stuff work. Uh, Okay, let's try building this. I don't need it to sleep at all. Okay. It works. It's working. Okay. So we are going now. Let me try. Okay. Do you see this number on the upper right? It's sort of like 2375. Now it's 30. Now it's 22. And now, if you watch, look at this, look at this. When I put my hand in front of it, the number becomes around 30. When I take my hand away, it's 22. That's because 22, 23 degrees is the ambient temperature in the room. And when I put my hand over it, it's around 30 degrees. Now, this isn't Celsius, right? So 30 Celsius to Fahrenheit. 86. That's really close to body temperature. That is the body temperature of my hand. It's working. It's working. I'm able to grab data. Now, let's try, before I go to bed, let's try getting this to output something to the screen. I am able to get a frame read in using the read pixels. Where pixels is a float buffer of size 64. This works well. Can you keeping expanding the main.cpp, can you have the program display something to the screen? Can you display the frame buffer, pixels buffer to the screen in some way? Easiest to and quickest to implement would be appreciated. Okay. Let's go see if that's gonna work. Let me go grab a glass of water. Okay, let's find out what it's having me do. Let me grab my mouse. Cool. Okay. Oh, God. Okay, so Mila decided to visit me. He's helping me. Do you have anything to say? Okay, let's see. You're displaying a pixel array as an image on the console is a common and effective way to visualize data. Since you're using quickest, we use ASCII art. Wait, what? Wait, hang on. Wait, hang on, what? Sorry. I mean something like, QT or QT, SDL, or UTK, or some other simple C++ way of drawing to the screen. Done. So basically, I'm not going to delete the other prompt because the other prompt could be pretty useful. Easiest and quickest ESDL seems to be the generally most straightforward of direct pixel manipulation, getting a window on the screen quickly without heavy widget-based framework. It's not SDL to development layers, so let's do that. Sudo apt install libsdl2 dev libsdl2 image dev. Okay. Yep, one installers. Scaled up. Cool. Cool. We're getting close. close, folks. Oh, Milo. You're so lovely. Here, what am I listening to, folks? Okay. Okay. Okay, let me read over this. This DL seems a whole lot like OpenGL. Screw it, we're just copying and pasting it, folks. We're just copy paste. And then we're just gonna we're just I don't even give a shit no more. Aww. He really wants loves. Cat? Yeah. This is Milo. Say hello. Say hello, Milo. Milo, are you trying to escape my clutches? Do you want to be anywhere but here? Okay. Yeah. Binks, the other cat is Binks, but Milo likes me. Anyway, let us just run it. Right. No, actually, important thing. Export display equals that, and then if I do this guy is not letting me get any work done. Sudo now sudo now dash rc. We gotta add it to the end of our bash rc file. Basically, when you do that, when you add the export display 0, it won't know which window to launch on. So that's why I have that. So let's try building it. Oh, of course. I wish you guys could see, but like he's coming up over the desk and he's smashing his head against my arms to get pets. Isn't that right, Milo? Yeah, man. See you, Reason. I'm glad you stopped by, homie. Glad you stopped by. it compiled. No way. Look at it. Here it is. It's my thermal camera. It's working. If you can see, look, my hand's closed. My hand's open. Look, I'm holding it with 2 fingers. I'm holding up 2 fingers. Look how fast it is. This is over SD. This is over VNC, so you know it's trash. Okay, so now I want to do normalization, but I want to use SIMD. That light, I think, is the ceiling light. Okay, so cool. Let's so it works. So I think the temperatures are in Celsius coming from the sensor. Is that taken into account? Dude, it's freaking working, dude. So the maximum temperatures are in Celsius. So if you go here and look, let's say the min would be like 0, and the max would be like. This is something that should be able to be like changed with like buttons. And we're gonna get there. We're gonna get there with buttons. Can this be auto scaling? I don't see any blue ever. So yeah, I want it to be auto scaling. You're right. Nope. Come on. Come on. Okay. There we go. Do you see a tail? Here's a tail. He's sitting on my window now. Cool. Now let's. So. Thanks a ton. The Adafruit the Adafruit Raspberry Pi example uses NumPy to do interpolation to smooth the image out greatly. It doesn't even look like you're using an 8x8 sensor. I want to do this in C, C++, and eventually I want to do it using Neon's SIMD capabilities. Okay, let's see if it can even approach this shit. Like, this is really awesome, honestly. This is really awesome. I think if I really wanted, I could do like high speed I2C. It might be low speed. High speed is 400 kilohertz, low speed is 100 kilohertz. Dude, there's no way it can figure this out. There's no way. No one uses Neon. Unless it has scraped even the ARM white papers. What? Didn't even finish. Yeah, let's try rerunning this. Rerunning this prompt. In theory, because my temperature is 0, I think, I should have the same exact, or temperature is 1, I should have the same exact output. Good God. This is the problem with vibe coding, is that you just end up, you copy and paste and you just have no idea what it's doing. Okay, use SDL. I don't know what SDL is. Like, I mean, I know what it is, but I don't know how to use it. I don't know why it's doing what it's doing. I would like to do OpenCV. You know, it says use OpenCV, but OpenCV just has so much overhead. It is insane. It's a deep but rewarding rabbit hole. Yeah, I think I'll do what it's saying, the ARM Neon. I'll try to do the intrinsics myself because I think that's really fun. So let's see. So yeah, you're aiming for a much smoother, more visually appealing output. The adequate by things people like uses by cubic interpolation, which is what SciPy ND image zoom does by default. The MIST method looks at a 4x4 grid source of the pixels and calculates the destination pixel, resulting in a much smoother appearance than simple bilinear interpretation. Implementing by cubic interpolation of Scratch is significantly more complex than bilinear, however, giving you the goal of Neon SIMB capabilities. A manual implementation makes sense as it gives you full control. And this is what I will do I will work on is the demo I want isn't that, oh, I can copy and paste code from, an AI. I want to be able to say I got the boilerplate done with an AI, and then I got down in the nitty gritty with ARM Neon intrinsics, and I made the shit as fast as humanly possible. And if I have a tripod and stuff to show, be able to help show you how I do this, then yeah. And also, I'm getting a sensor. This is an 8x8 sensor. I'm getting a sensor that's 32 by 24. I think 32 by 24, I can make it look like. I think I can make it look like a 320 by 240 sensor. I really do. If bilinear is not smooth enough, we can discuss bicubic. Bilinear interpolation. First, quickest and most straightforward for a custom Z++ implementation while giving it an improvement will increase the target resolution. The interpolation function. So basically it's saying add this function to like an H or an H or your main. And I will go in and I'll look at this and look at this garbage. Look at this garbage. Is this actually like the best way to do it every freaking frame instead of just like a lookup mod or something? Well, that's the thing, because this thing, you read floats, but you won't actually read floats. You read integers. You use 12-bit integers. And I just wanted to read pixels, not read I want to read pixels raw. Read pixels raw is something I will actually use. There is convert the raw to float. This is setting up the renderer, blah 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 blah, and temp. Huh. This is basic. This looks like a horrendous way to do it. Horrendous. I'll probably not. I'll have an auto scale mode, but then I'll have manual. Let's slide the high and low scales. See him? There he is. Yes, Milo. And I'll need buttons for this. And that I can do. That I can do. What am I listening to? By the way, I'm getting married. In a month. That'll be cool. Okay, let's get this done. One of the great interpolation includes SDL, blah 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 blah. We're just gonna put it in here. Yeah. Basically, it wants me to do an extra H file because that's where I'll do neon. I think it'd be really cool to do an assembly too if I really wanted. Because, yeah, I don't really care about everything else. I just have to do it fast, you know. How do I see? Because then I could say I can seamlessly integrate assembly and SIMD instructions into C and C++ even to create the most balanced, fast. I want the fastest. The fastest, don't you think, Marlo? You want the fastest camera in the world. You want the fastest 8x8 pixel thermal camera ever. Okay. This is bilinear. Bicubic apparently is better. Right, Milo? I don't even understand that. Yeah, he wants his pets. He really wants his pets. So basically, and this is not a full implementation of SIMD, I think partially because it knows I want to write it, and partially because no one writes in SIMD. I mean, they do, but it's not really like a ton on GitHub. So basically, inside it, imagine processing 4 output pixels, so it can do 4 pixels at a time. But like, so this is F32, so it's doing floats, and I'm not gonna do floats. I'm going to be doing ints. So I'm going to sort of like revisit that a little bit. Okay, let's find out. Look at this. Here, let me. Isn't that cool? And look how fast it is. And again, this is our VNC. So like, isn't that so cool? It doesn't look as good. But I think that's the smoothing method. So maybe I could say I want bicubic instead of bilinear. But look at that. Okay, so I think I finished what I wanted. Um, Later I'll change it to ow cat. I'll change it to bicubic. I think maybe that's gonna be a little bit better, and then I'll change the auto scale from auto scale to like fixed scale and auto scale. Use buttons. But at this point, I got a good boilerplate for this whole thing, so I'll go and I'll separate everything out into separate files and put it in the CMake. Yeah. And then once I got all that, then I will focus on turning this into neon and into neon functions. Right, Milo? Okay. Well, with that, I will head off to bed, and I will probably stream this again at some point very soon. And also the OpenGL engine I will stream again very soon, possibly Saturday. Or Sunday. Okay. Well, oh man, you joined, man. I don't know who you are, but you joined. And as you can see, I have it working. But unfortunately, I was just about to head to bed. I'm so sorry. You didn't miss a whole ton. Most of it was just fighting the Raspberry Pi. But yeah, other than that, I was fighting the Raspberry Pi. But I got it working. I got bilinear interpolation working. This is an 8x8. This is an 8x8 sensor. So it's a 64 pixel sensor. And this is a cat. Yes, this is a cat. But it's a 64 pixel sensor, and it's working. And this is over VNC on a Raspberry Pi. So, any lag is probably nothing like what likely to be directly. And again, this is like the most unoptimized code. This is not optimized at all. This is like calculating mins and maxes every frame. This is also calculating the map each frame instead of doing a simple just lookup. But yeah. With that, I'll head off to bed. I'll see you guys later.